And we come to our fourth speaker now, who is Stefan Spettel, who is the co-founder and CEO of Phine.tech, that is a startup in Austria. Phine.tech works on, well, realizing, enabling, and also simplifying many of the 5G use cases. They are an active user and also contributor to OpenAirInterface, and as a contributor in particular also to the core network. And as such, he will now talk about using the 5G APIs that are a crucial prerequisite for AI-enhanced 6G use cases, according to Stefan.
Thank you very much, Robert. Yes, I'm very happy to be here at the OAI workshop again after 1 year, missed the last one. So yes, Phine.tech about 5G use cases. It aligns really well with what we have seen today in the talk about TSN. There is a lot of synergy here with the team of Martin and AirPulse, and also the talk we just had now, and of course also about from AllBeSmart. I'm very happy to be in this session because I think it aligns really well. But today I'm not going to talk about TSN. I will be talking about 5G APIs. So this is going to be a lot about the core network. So why am I talking about the core network? Because we really see that to have these end-to-end use cases, we need to go beyond the edge. Because we have the RAN, we have the RIC, we have just heard a lot about that very nicely. But all these need to work together to really have an end-to-end use case. So we have the O-RAN, we have the RIC, which really unlocks a lot of intelligence at the edge, RAN. We have the XApp, so, again, various use cases. But the problem is a little bit that the core still remains kind of siloed. So for all these end-to-end use cases, the core is somewhat just there, I want to say. So what we really need here is a holistic solution. So really to unlock the whole value for the whole ecosystem. And to unlock this value in the core, it's really that we need these programmable core network APIs. And really foundational for all these next-generated AI-orchestrated intelligence. Because what we see now currently, we have intelligence silos. We have 3GPP network functions, all the core network functions, and we have AI agents. The AI agents, normally, they have blind spots. They don't really understand so much what is happening in the network. They operate over the top. Maybe they optimize a video codec, but they will not optimize the network status quo. So in order to solve that or to improve that is to really have these programmable APIs really in use. And they must be robust, and it's really a crucial prerequisite. And also, I was talking about robustness. It's also about simpleness, because we can really see this whole 5G core network APIs are very complex. And what we are doing here is to use Camara APIs. So we bridge Camara APIs with 3GPP network functions in the core network and these AI agents. I have an architecture here. So this is basically how we envision this whole thing to work. Let's imagine there are robots operating in a fleet. So we have a fleet operation connected to 5G. We have network analytics, so we have some kind of network data analytics function or some function that does some intelligence in the network. And we also have an intelligence layer, which I just called now the AI layer. We have an agent here, and we also have MCP in place, so the model context protocol. And as you can see here, this is the whole architecture. I skipped some functions from the core network to just show the relevant one here. And then, of course, we have the RAN, and we have some UEs on the RAN. Sorry, we have some robots as UEs, many robots, because we're maybe talking about fleets or a drone swarm. And then we have the N6 LAN, the application where some kind of robot control application is running. Now, let's imagine a scenario there is a congestion. Let's imagine one of these robots is driving into a dark corner of the factory, meaning there's an upstream video, and this video codec needs to increase the bandwidth for people to still see something. It's a very common thing. What should never happen in that scenario is that all the other robots have troubles in receiving control messages, emergency stops, etc. So we have this congestion, and then we have the network data analytics function, which is able to detect this based on all the APIs that are working. So the NWDAF detects this congestion and sends a notification to some kind of application function or network exposure function. For this scenario, I skipped the network exposure function. We assume this whole AI agents are trusted parts of the network. Just for simplification, but in the end it does not make a big difference. So now we have a notification on the application function, which sends this notification to the AI stack via, again, the MCP. And the AI agent now has this information, there is a congestion in the network. And this we are delivering using Camara. For those who don't know, Camara is basically a set of telco APIs which simplify the, I would say, core network internal APIs. And it's also simpler from a developer perspective, but here we're not talking about developers, here we're really talking about agents. So anyway, this agent gets this notification, and then in the end now the agent needs to do something. So it knows, okay, there is a problem. Now, and this is very important in the way we envision that, is that basically the agent has the context of the application. The 5G, 6G network does not have any context. It does not know about how, okay, it knows how many robots because it knows how many UEs, but it does not know exactly what are the requirements of the application. The agent knows that because the agent also communicates with the application. And in the end, the decision-making here needs to be outside of the network. The decision-making needs to be on the AI agent level. And then we use this MCP as a bridge. And for MCP, basically it can call a lot of different applications. And in the world of these agents, it's just a tool. So all these 5G APIs, Camara APIs, could also go directly core network X apps, as we have just seen before. These are just tools the AI agent can call whenever it needs to, or it decides to call them. So yeah, in the end we have a tool discovery, so the AI agent thinks, okay, now is a good point to enable a Camara quality on demand flow. So yeah, basically we are doing that. So we have the quality on demand API from the Camara, which is here, by the way, utilized by the application function. And then we have this whole quality on demand flow that is happening. So we started the agent sends it to an application function via Camara. Camara sends, application function sends it to the PCF, PCF sends it to SMF, SMF to UPF, and then also, of course, to the RAN and to the UE. There is a lot of things happening right now in the network. And basically, it's just about installing new QoS rules for this specific situation. And of course, UPF and GNOP are the ones enforcing this QoS. So what has happened now is basically then the quality on demand API from Camara, for example, notifies the agent, hey, everything went well. This one robot in the dark corner has been reprioritized, and now everything is basically going back to business as usual. So now we have the network data analytics function doing again their connectivity monitoring, could be predictive monitoring, but could also be on demand. So the congestion is avoided. We have a QoS prioritization that has happened end to end. So in the end, this whole flow was really zero touch. We can really see it's a fully closed loop execution. There was no human pressing a button or changing a configuration. It was an AI agent outside of the world of 5G, 6G, deciding we need to influence the network. Yeah, and this is the way we can do that. So this was basically our vision, how we think this is going to happen. And now I want to talk a little bit about our demo tomorrow, because our demo follows really the same principles, and I would like to take the space now to talk about it because the architecture is a bit convoluted. So what we did in the demo here that my colleague Lucas will present tomorrow is basically we combine robotics, quality on demand, and 5G, everything together. So we have quality on demand, again using Camara APIs. We have our own application function, which we call Phine application function, which acts as a Camara and N5 gateway. N5 is the interface between AF and PCF. And then we have something we call 5G ROS gateway, and 5G ROS gateway speaks the language of the robot. So there is this protocol called data distribution service, yeah. And this one communicates on the ROS, on the robotic stack, but this one is also able to understand what kind of QoS requirements does my robot have. And then it can start this whole closed loop interaction. So in the end, it's really end-to-end. We have ROS, DDS, Camara, 5G, and then in the end, APIs, and then in the end, it goes towards NAS, towards the UE. So everything here is involved. This is basically how the architecture looks like. So So I just need to go here to see that myself. It's a very small screen. Yeah, as you can see, we have the core network here, which is orchestrated by our tool we call Virtual 5G Lab, which orchestrates the whole core network. On the right side, we have the Phine application function using the policy authorization API, having what we call AF core, which is the business logic, and then we have the Camara QOD API. Then in the data network, we have the 5G ROS gateway that is living there and is monitoring the whole traffic of the robot. What is happening, subscribing to events of the robot. You have to imagine this ROS and TDS works a little bit like MQTT. It's basically a publish-subscribe mechanism. So this one subscribes to all the changes and then informs the network, hey, I need quality on demand for a new video stream, for control messages, whatever the robot needs. And then, of course, we have the RAN, so UPF, of course, as well, and RAN from OAI. We use RFSIM here, and then we have our tool, which we call RoboSIM 5G. And this logo, by the way, this icon is from Gazebo, which is a robotics 3D simulation. I realized today in the morning it looks very similar to the 6G sandbox one, but it's not related to that at all. So this is about Gazebo, which is an open source 3D simulation tool for robotics. And what we have done here is we have integrated the OAI G-Node B and UE inside there. So the whole simulated robot communication goes over the 5G network. Yeah. So this is the end-to-end architecture, and this is more or less the flow that you're gonna see tomorrow. I'm not sure how many time. Yeah, I can go through that. So just to what I have just explained with the chart is basically how that happens now. So does that work? No. Point is not. Yeah, someone. Yeah, okay. Point is not visible, so we have to start at the left. So we have the application function that sends a request to the PCF. Then we have the PCF, which sends new policy rules to the SMF. And then we have what we have also seen in the talk before. We have the whole N4 PFCP messages. So we have a session modification that is happening. And then we have the N1 and 2 signaling from SMF via AMF to G-Node B and then to UE. And obviously, the whole N1 communication is not going from AMF to UE. It's obviously going via G-Node B. It's just easier to show it here. And then we have the whole thing in the other direction. So this is the whole end-to-end quality on-demand flow. So whenever an agent decides, oh, I need to change something, I need to reprioritize something, the 5G network is doing exactly that. So this is basically the whole flow here for the demo tomorrow. So you can see that, and you can also see that visualized in our virtual 5G lab tool. Yeah. I want to take the time to talk a little bit about the Phine application function. So it is really a modular architecture. We have the southbound APIs. We have the N5 interface currently. We have the core, which is the whole business logic, which connects the northbound and southbound. And then we have northbound adapters. And what we have here is, on the northbound, we can support a lot of different protocols. Currently, we support Camara Quality on Demand, but we also support gRPC applications. So you can write your own gRPC-based application, and you can just do remote procedure calls to that application function. HTTP REST is also currently working on, I would say, but that's going to be there soon. And then you can even have your custom protocol, like we did here with the ROS protocol. And on the roadmap is, for example, other Camara APIs, device location, traffic influence, very important for all these end-to-end use cases. And then probably also the N33 interface, which would be the network exposure function. And the good thing about that, currently this is closed source. We're still in development, but we will open source this application quite soon. And we will integrate it quite tightly into the OAI ecosystem. So whenever we have an end-to-end use case here, with the application function, we have also an open source Camara gateway, so to say. So we really can bring these Camara API use cases into the open source world, which I think is very nice. End to end, the whole network. One note about the core network, because maybe you were paying attention, you didn't see the OAI logo at the core network in the graphic. For this end-to-end use case tomorrow, we are going to use FreeE5GC core network. And I want to tell you why. Because basically this whole end-to-end N5 procedures are currently not supported in OAI. QoS is supported, as we have seen just before, but this needs to be statically provisioned. So what is really missing is this whole N5 and 7 procedures. We are still using the OAI UPF because OAI UPF is able to handle all these PFCP session modification things. The good thing here is, for the demo tomorrow, we use 353C because it was there, and it came from another project where we had to use a core network which works for this specific use case. The very good news here is that we are, together with the OAI team, and especially together with Saga and Shubika and everybody from the core network team, we are going to implement these procedures on the OAI core network. And we are actually planning to open source that very soon, so I think after the summer, in September, we should have the first end-to-end QoS quality on demand workflow also in OpenAirInterface. And that's it, everybody. Thanks a lot. I'm very happy if there are any questions. It's the break, so.
Maybe. Then let me maybe ask one question. So I'm from the RAN side of things, so I might not be aware of all the core network. But at some point you said that there were, like, if I understood correctly, like shortcomings in the core network. But my understanding was that the service-based architecture was made so that you could extend this more easily. So is there a shortcoming, or was this actually the service-based architecture helper to implement this use case, and how does this fit into the spec?
And also to the evolution of that. Yeah, actually very, very good question. I've been thinking about that myself. I think there is, first of all, I come from 4G, so I hope I don't insult anybody. I really don't like diameter. I don't like the diameter protocol, which was used heavily in 4G. So I think this switch to going to the service-based architecture using REST APIs was amazing. And I think it was really the right direction. It is getting very complicated. It's very complex. Whenever you have microservice architecture, it's complex. And I think the role of 6G and this whole AI topics, this whole intelligence we're talking, is to simplify and automate that complexity. But I don't think we should go back to merging this microservice together to make an MME out of it, because we have been there, it does not scale so well. The beauty of the 5G core architecture is it works in an operator network, but it also works in a box. And this is really nice that it can just grow and scale. And I think for 6G, we should not reinvent the wheel. We should stick with this architecture, and we just update that. And whenever we have new use cases, let's say ISAC, and let's say a core network part is important for that, we should just add another another network function which does that. So I don't think we should just reinvent the wheel every 10 years.